How's it going, everybody? In this section, we're going to talk about gateway redundancy and basically what it is and how it works and the different aspects to it. There's actually three different ways we can do it. Two of which are just automatic failover, if you will, of the actual default gateway information, and one is open standard, which is the HSRP. The other one is open standard. One is Cisco proprietary, which is HSRP. The other one is open standard, which is VRRP. VRRP was the IEEE's response to Cisco's implementation of HSRP. The idea behind both of them is actually identical. Just a small tweak in the naming convention, and the config is almost identical. So when I go over one, I won't even have to really change anything over. It'll just be a matter of turning HSRP off and turning VRRP on. Now there is GLBP, which allows you to use multiple active routers at the same time to allow for what they call load balancing. Load balancing is just a simple term used for if you have two routers that connect off to the internet, you could use both of them to get your traffic out to the internet if you need it. So with HSRP and VRRP, if the primary router goes down, the secondary will pick up for it, and it'll be almost transparent to the end user. So end hosts typically do not route into the network, they default into their gateway. So if the gateway is down, connectivity is lost. FHRPs, or first hop redundancy protocols, allow another device to take over for the host's default gateway if it goes down. Transparent to the end host, no need for dual gateways in DHCP. So remember, everything when it comes to Ethernet, ARP is the glue. So if I am host A and I want to communicate with host B via IP, if host B is on my subnet, check the ARP cache for host B's MAC. If no MAC, ARP for host B's MAC address. If host B is not on my subnet, check the ARP cache for gateway's MAC address, and then if no MAC, ARP for it. ARP is just a simple way of saying, hey, can you give me this MAC address? That's all it is. It's a request. There's also a thing called gratuitous ARP. Gratuitous ARP would be the exact same thing as if you were to go to a restaurant and have a server serve you food, you would tip them for their service. Some servers are pretty bad, so typically you wouldn't give them any tip at all, or maybe just a few cents to show them that either their service was really bad or some other thing. I've actually seen people take a cup of water, put a penny in it, and then they flip it upside down to where they had to physically pull a cup up to get the penny out. I have not personally done that myself, but I have seen it. Where when you have a server, I forgot where I was going with that. Anyway, the idea behind gateway redundancy is multiple routers bundled in a group, and group responses represents a virtual gateway. So the group is just a term used to signify a specific location. So all routers know virtual gateway IP address. The active physical router responds to the ARP request. The virtual MAC address is used in the ARP response. So the virtual MAC address can be used by two different devices, so that ARP caches don't have to be flushed every time a gateway goes down. It's just a matter of, okay, who's the gateway? The end user never knows. They just know that they can still continue to forward. Host configured with the default gateway IP address equal to the virtual IP address. So what would end up happening is, if you're going to use DHCP, which we will configure in here just so you guys have an idea as to what it looks like, routers, what will end up happening is the default router command will actually be the HSRP or VRRP IP address, the virtual one. So we will use that as the default router, and no matter what device has it, that IP address and then the virtual MAC address that's associated to that IP address will be what the end users learn. And so when we do a ping, the ARP, when we do a show ARP on the routers, we'll see how this works. So and then there's three major protocols. Like I mentioned, there's they have the same major functionality, is to provide redundancy in the layer 2 environment. HSRP, VRRP, and GLBP respectively. HSRP, is just a quick review, is a hot standby router protocol. It elects an active gateway based on a priority. the 100 is the default priority, and the maximum is 256. Higher value for the priority is better. So if there is a tie, then the highest IP address is the tiebreaker. It is non-preemptive by default. Preemption is the overthrowing of a lower value priority device. So if you have router 1 has a priority of 110, router 2 has a priority of 100, and router 1 goes down, router 2 takes over for router 1. That's the idea of redundancy. Now if router 1 comes back up, he will preempt router 2 and say, okay, I'm back, I want my active forwarder role back, and then router 2 will then go back into the standby mode, router 1 will take back over, and everybody will be happy. So because it is Cisco proprietary, it is only available on Cisco devices. So communication via UDP multicast to 224.0.0.2 on port 1985. That simply means the multicast address 224.0.0.2 is the all routers multicast address, and as long as you're not filtering UDP on port 1985, you should have no problem. Messages can be authenticated using clear text or MD5. We will be doing all clear MD5 because that's exactly what you're going to use in the real world. Supports multiple groups per interface, so the group ID is encoded in the virtual MAC address, where this section right here is what indicates that it's going to be HSRP. This indicates the group number. So it operates in an active standby setup, so active forwards for virtual MAC, standby checks to make sure the active is up. If you don't, if down, it takes over for the MAC address. Standby interface level command. Typically what people will do is they will use some sort of object tracking. Excuse me. What they typically will do is they will track the interface that the traffic will be coming in on. So if, for instance, you're using fast Ethernet 0/0, they will track FA0/0. If that goes down, then what will automatically happen is the other router, R2, will automatically take over once his keep alives fail. By default, it's 3 seconds for hello, and he will wait for 3 full and 1 partial failure before he will reconverge. So it's 3 seconds and 3 failures, 3 full complete failures. So 9 total seconds. And the beginning of the 4th hello, that's when the failure would fail over. So it would take up to 10 seconds for HSRP to fail over. We are going to work on the convergence timers with that and get it to converge much, much quicker. So, typically you could use IPSLA, which is going to be giving you the option to go a little farther with your config. So you can actually ping the remote IP address of a switch or a device, and you could ping it, and if it fails, you could have failover rather quickly. And you just, if you were going to do this, you would configure, what you would call it, you would configure it to where you would go in there and you would type in track object, or standby 1 track whatever, and then you would, after you configured IPSLA, you would track the object from there, or you could just track interface and whatever the interface is. So this is our topology that we're going to be working with. As you can see, it's pretty straightforward. So R1, let's beef this up just a little bit because that's a little small. And we're going to go to red. Red stands out. So we're going to start right here. This is going to be our initial router. This guy will be the backup. And R2 and R6 will use R1 out of the gate, and then R4 to do all of its things. So what we're going to do is we're going to pull up, I have you guys on my secondary monitor, so I'm going to be doing a lot of back and forth stuff with my config. So let me pull up this guy. It says, the design team has mandated that the primary link to the internet should use R1's link to ISP1, and that HSRP should be used for redundancy. For this connection, configure HSRP on the inside interfaces of R1 and R4 per the following specification. So what we're going to do now is on R1, we have a duplex issue. So what we're going to do is we're going to bring this guy over, and it says let's scoot this guy over and then down just a bit. And it says, first thing that we're going to do is we're going to verify that we have reachability to the areas we're going to work in. So show IP route. We have OSPF running, so we should have some OSPF routes being converged. So we're going to pull up our site here, and we are here at R1. So we're going to ping, let's see here, 10.100.14.2. There we go. Cool. So we can ping that one in .6. The reason I'm pinging those is so that the ARP cache is built. And there they go. Now, we don't have HSRP running right now. So if we do a show standby, HSRP is not working. So we'll have to do is we'll have to flush the cam table. I just want to make sure we have reachability to the different routers. So now if we do a ping to show IP interface brief, we are 14. So if we ping 4, we probably won't get a response. Oh, we will, because I know this. It might be coming from. I think this interface right here is passive. But anyway, what we're gonna do, since we have reachability to everything and everything's working the way it's supposed to be, what we're gonna do is we're going to go to config t interface fast ethernet 0/0, and we're gonna type in a standby and then the group number. So we're going to pull up our thing right here, and we're going to type in the let's see HSRP. We're going to use it doesn't tell us which group number, so we're going to use group number 1. HSRP standby IP address is going to be this guy, and we're going to use 10.100.14.254. Oh, standby 1 IP. So there's the IP. This guy should be the primary gateway, so we're going to put the standby. Everything starts with standby, the group number, and then what we wanted to set up. Priority is going to be 150. And then what we're going to do is we're going to type in, it says if R1 is unreachable or its link to ISP1 goes down, R1 should, or R4 should take over as the primary gateway. If R1 goes down and then comes back up at a later time, it should resume its role as a primary gateway and after being stable for 30 seconds. So those two lines right there should tell us that we need to standby 1 preempt, which will overthrow a lower priority value once this guy comes back up. And we're also going to type in standby 1 preempt, and then we're going to put in the delay is going to be, we're going to say, I think that is, we're going to, minimum is going to be 30 seconds. So that's after everything is stable. So we're going to do that. And then what we're going to do then is we are going to use standby 1. We're going to track. Actually, what I should do here, I'm just wondering if they configured IPSLA. So we're going to check real quick. Yeah, they didn't actually use IPSLA. All they did was they tracked the interface and they gave it a decrement. So that's what I'm going to do. I just wasn't sure what their config was going to look like, but now I know. Standby 1, and then we're going to track, and we're going to track the interface serial 0/0, and then we're going to decrement 60. And what that's going to do is when we get R4 configured, then we're going to go ahead and get it set up for, we're going to set the value at 100, which is going to be the default priority. So as soon as R1 goes down, he's going to decrement his priority down to 90, and then that'll automatically trigger R4 to flip over. So we're going to type in standby 1, and then with question mark, you see authentication hanging out there. We're typing authentication, and then we're going to use, it says MD5, and it's a key string is going to be, and we're going to type in dbm underscore HSRP, and we'll use that on both sides. So actually what will end up happening now is it'll go down. So we're going to type in standby OneTimer, and we're going to say the hello interval is going to be it says 333 milliseconds, so we're going to use millisecond is going to be 333, and then the millisecond for the hold down timer, millisecond, is going to be, actually I should say, is just going to be 1. So you type in millisecond, it's going to tell it to look for it in milliseconds, and then the 1 is just going to be in for 1 second. So it's going to send 3 hellos a second. If 3 are missed in a row, it'll fail back over. So that'll be how that works. So now what we're going to do, we're going to jump down out of here, we're going to do show standby, and then I'm going to go through here and explain how we've got everything situated. So what we're going to do is we have standby, let me scroll this down just a little bit. We have fast Ethernet 0/0 as group 1. State is active. Let's see, we have virtual IP address is this, the virtual MAC address is this. This right here indicates the group number, just the 01. Trying to highlight just the 01, but it's not working out. Local virtual MAC address is this. Hold down timer, hello timer is 333 milliseconds. Hold down timer is 1 second. Authentication is a dbm HSRP. Preemption is able. Delay is a minimum of 30 seconds. This is the local active router. Standby router is unknown. So if we interface changes down, then the we're going to decrement 60 from 150, and that is going to change this down to 90. We're going to jump over to R4 now, and we have quite a few config T interface fast Ethernet 0/0. We're going to say speed is 100, a duplex full. You need to do that on fast Ethernet interfaces because the fact of if you don't specify the speed, it won't take the duplex. So what we're going to do is I'm going to come over here and I'm going to do a show run interface fast Ethernet 0/0. I'm going to copy all this over, except for I'm going to pull this up. Actually, I take that back. Pull this up, bring this down, and I'm going to copy this in, but I'm going to tweak it just a little bit, just so you guys can see what this looks like. And so we're going to come up here, and then we're going to do this. What I'm going to do is I'm actually going to take this out, and I'm going to take the priority is going to be 100, and I'm going to take this out. So now all this right here is going to be what we need to do, and then we're going to jump over to R4, wherever it may be laying. There it is. Scroll it up here. We're going to I can easily just take some of this stuff out. Control A, no. And this guy, no. If you don't change anything, the defaults will automatically be there. And preempt delay is going to be no. Preempt delay. So if we do a show standby, we have preemption is enabled. We have the active router is .1. Minimize this. And so what we're going to do now is we're going to go to R2 and we're going to ping. Let's do this. And we're going to, let's see, we have config T interface fast Ethernet 0/0 is speed. Actually, let me show you the duplex full. Oh, I did take it. Okay. Well, I guess it was auto negotiating it. But so anyway, we're gonna do an end out of here, and then we're gonna ping. Alright, so let's do a show ARP real quick. Show ARP and .1, and then what we're gonna do is we're actually gonna ping 10.100.14.254. So we can ping that. We're going to do a show ARP now. As you can see here, we have, this is it. Okay, so what I'm going to do on R1 is I'm going to come up here and I'm going to go to interface fast set of 0/0 and I'm going to type in shut. But one of the things I'm going to do is I'm going to slide this over here just so you guys can see it. Do a shut, and then what I'm going to do is I'm going to keep this live so you guys can see. I'm going to ping. Okay, so I see what happened. I'm going to ping this, but I'm going to repeat 100 times, just so it gives me, actually let's do 1,000 times, so it gives me the time to do this and do the shut command. So I'm going to hit enter. Notice how we only lost 2 pings. So basically what ends up happening is, we can just do Control-Shift-6 on that. So what we had happen over here, let's take care of that. I guess that didn't actually take care of it. Interface fast Ethernet 0/0. We're going to do a speed 100 duplex full. That should take care of it. So, alright, cool. So what it basically said is, on fast Ethernet 0/0 for the HSRP, it went from active to a NIT because we shut the port down. Shut the port down. What ends up happening is we go within 1 second or thereabouts. We went from the active standby to active. So the only thing I'm going to do, I'm going to go up here and I'm going to type in enable password is Cisco, and I'm going to go underneath the line VTY 0/4. I'm going to type in login, and the password is going to be Cisco, just so we can telnet to these devices. And I'm going to do the same thing here. I'm going to go exit out here, enable pass is Cisco, and line VTY 0/4, and I'm going to type in login, and pass is Cisco. So I'm going to go to interface fast 0/0. I'm going to type in no shut, and as soon as it comes back up, it flips it back over to speak. It's talking to this guy, router 4. It's in standby, and he should preempt back over to show standby. This guy is a standby. Oh, I'm tracking interface 0/0 or serial 0/0. So oh, there it goes. Now it's in standby. So preemption did work. It just took a little bit longer than I was anticipating. So what I'm going to do is I'm going to go back to this guy, and I'm going to, from here, I'm going to drop out, and I'm going to telnet to 10.100.14.254. It's open, Cisco, and we're on router 1. Alright, so we're on router 1. That's what I wanted to show you. So now what we're going to do is we're going to exit, get out of here. Now we're back on router 2. And what I'm going to do now is on R1, I'm going to do config t interface serial 0/0. I'll type in shut, but over here I'm going to hit the up arrow. I'm going to do that long ping again and jump back over to R1 and do this again. So we had that long ping, and then it should. Okay, that went a lot quicker because of the fact it was actually watching the decrementing. So if we do a do show standby, right now the priority is 90, and we have the decremented 60 from that. So this guy took over. So within a pretty quick amount of time, it didn't take long at all. He went from speak to standby. He detected the link down, and he went to active within 1 second. So that is actually what we were looking for. So I'm happy with that. So now we know how to configure all that, and if we were to do a debug of information, we would see that this information going back and forth. Now I'm going to do a no shut and see how long it takes for it to fail back over. And if it's back up, the tracking state is from down to up, the protocol went up, and I'm just waiting for the preemption to happen. Now remember, it's going to wait 30 seconds to see if it's stable. So it's not going to happen right away. I forgot about that a moment ago. It's going to wait for 30 seconds for this guy to be stable before this guy will take over. That is one of those optimization things that if you don't do it, you can run into problems. I've never actually used that in production, but it is definitely something that we could definitely take a look at, and now we're active. It spent 30 seconds. Just to be exactly 30 seconds. So we did the no shut right here, 57, and then almost 30 seconds to the T, it came back up. So that's a good sign. Everything's good to go at that point. So as far as I'm concerned, let's look at the what they said we should be doing for the solutions. Okay, it says to test this configuration, ping from R2 and R6 to the internet address of 3.3.3. I bet you that's going to be. I bet you 3.3.3 and R5. So let's go to R2 and let's ping 3.3.3.3. I bet you that's R3's loopback, and I bet you we can do the same thing for 5. And we can ping to 5. And what I'm going to do is I'm going to ping to 3, and I'm going to take the port down one more time just to test it, because I didn't remember that part. So we're going to do the shut. I'm going to do the extended ping. I'm going to repeat 100 times. Now it's destination on host unreachable, and then it came back up. So anytime you see the U, that's destination host unreachable. And so right now we are in a good sign. We're pinging, everything looks good. So we're doing exactly what we were supposed to do. And as you can see, this guy, he flipped over pretty quick. It was he flipped over pretty quickly. So now what we're going to do is we're going to do a no shut and do the exact same thing. If we do this again, we type in no shut. It's not going to affect this guy because he's going to wait 30 seconds before he gives it up. He's like, wait a minute, dude, I've got things going on. Now what I'm going to do, as soon as it's done, I'm going to do over here, I'm going to do a show ARP. Regardless of what we do, this guy right here, this is the default gateway. So we do a show run include IP default. Right here, IP default gateway is this address right here. So doesn't matter what any of these addresses are. In order for R2 to talk to anybody, he's either going to hit this guy or this guy. So even if he's pinging here or here, it does not matter. So as far as I'm concerned, everything's working the way it's supposed to be. So that's HSRP. So we can play with other there's other things we could play with when it comes to timers and such like that, but right now I feel like we're in a good spot with the way things are set up. So that is HSRP. I'm actually going to check the config real quick to see what they did. So we have the standby IP address, which automatically we have the timers we modified. I didn't do the priority because really the priority is not that big of a deal. You can do whatever it is here, whatever device you're going to actually do the decrementing on. That device, as long as you're decrementing more than what the priority of the standby address is going to, or standby device is going to be, then you should be fine. That's not going to make much of a difference. They almost have duplicate configs, except for the fact of this guy is set up to preempt, except he's got a delay minimum of 30 seconds, and the priority level here is 255. So basically, he's taking all of his delay away and giving it to this guy, and he's got a default of 100. So that is how we did that. The standby address and information like that is obvious because we went through that. So the idea of going to the interface and shutting it down and watching the failover, I actually got it from right here. But like I said, it's one of those things where you have to test this out in order for it to work and see exactly how it's going to do its job. So we did some traces, and actually I didn't trace from router 2. But anyway, so what we're gonna do now, we're gonna get into VRRP in the upcoming video and get into how that works. I hope this has been informative for you, and I'd like to thank you for viewing.